Okay, we are starting the famous slope-intercept lesson today. The most common equation that you will see from now on in 8th grade, and 9th grade, and 10th grade, 11th grade, 12th grade, and all through college is slope-intercept. Slope-intercept form is y equals mx plus b. Do you remember what I told you m meant?
No.
I said it. Slope, you already knew. The m meant slope. The m meant slope. So when I have y equals mx plus b, these are constant. This will always be there, the y and the x. But the m and b are super special. They tell us really important things. The m, as I told you prior, is the slope. Every line has a slope, or an undefined slope, or a zero slope, but it's got something that goes there, Drew, right? Every line has some kind of slope. And this b is something interesting. It is what we call the y-intercept. And when I use y-intercept, when I say y-intercept, I want you to try to visualize, what do you think y-intercept means? Okay, when you think about an intercept, what do you think that means? If I have a graph, and I'm going to make a good graph. A good, nice and easy graph. And you're going to learn the graphing part later, but let's say I have this. I have this line. And I say, okay, what is the slope of this line? Slope is rise over run. Remember, slope is rise. So I say, how much did I go up? How much did I go over? So I look at this line, and I say I went up 1, 2 spots, right? The slope is 2, and I went over 1 spot. That'll always be the case. Up 2, 1, 2, over 1. Okay? And then we have y-intercept. And then when I say y-intercept, what do you think y-intercept means? Y-intercept. Y. Y means the y-axis. Intercept means where I crossed it. This right here, this beautiful point, represents the y-intercept. We call it abbreviated y-int. So the y-intercept, what I want you to put in your notes, is where we cross the y-axis. So slope and y-axis, that's all you need to know. The y-intercept, slope and y-intercept. Okay, our learning target today is just, if I give you an equation in slope-intercept form, your expectation is to be able to identify what my slope would be and what my y-intercept would be. So we're not actually doing any major application of slope-intercept, we're just identifying. We're being able to see where's the m, where's the b, and knowing that the m means slope, the b means y-intercept. So under the m, write slope. So pretty much the slope is whatever is in front of the x. The slope is whatever is in front of the x. The b is your y-intercept. We're going to call it y-int. Okay? So y equals 3x plus 2. What's my slope? What's in front of the x? Say it aloud. 3. So my slope is 3 on this line. What's my y-intercept? 2. So if I were to quickly graph this, I can graph it pretty easy. And you'll learn graphing tomorrow, but I'm just giving you a preview. I know that my y-intercept is 2, so I can make a dot at 2. And I know my slope is 3. 3 is actually 3 over 1. So it means that I'd go up 3, 1, 2, 3, over 1. That's over 2, but pretend it was over 1. And then I can easily make my graph. Okay? The next one, y equals negative 4x minus 2. What's my slope? What's -4? My slope, what's in front of the x? This is my slope, because it's the m. My slope is -4. What's my y-intercept? Negative. It's not 2, because this is really, because it goes y equals mx plus b. Well, this is a minus, so you have to turn it to plus b. So my y-intercept is a -2. So that means I would go down 4 over 1. My rise is negative for my slope. So this would mean I'd go down 4 over 1, down 4 over 1. And it means that I cross my y-intercept at -2. The next one, what's my slope on this next one? 2/3. That means I go up 2 over 3, up 2 over 3, rise over run. Rise over run, right? And what's my y-int? 5. So if I were to graph this like we're going to do tomorrow, I would make a dot at 5, and then I would use my slope. Rise up 2, go over 3, make your next dot. Okay? Okay, our last target for today, as an introduction to slope-intercept form, you're going to create an equation from a slope and the y-intercept. What we have to keep in mind is we always make it look like this. This is called slope-intercept form. That means I have a slope and an intercept, slope-intercept. So I always want to put the slope in front of the x, the y-intercept after. So if I have this situation, a slope of 3 and a y-intercept of -5, what do I put? Y is equal to m, what's my slope? 3, 3x, plus my y-intercept. What's my y-intercept? -5. You will never see it like that though. How do you think you're going to see it? Yep. You're going to see it, y equals 3x minus 5. That's how you'll see it. Some students, if you're struggling with this, know that m is slope, b is the y-int. And so what I did when I first started this, if I knew my slope, I said m equals this. And if I knew my y-intercept, I said, okay, that's my b equals that. And then I turn it back into that equation. Y equals mx plus b. What's my m? -2/3. What's my b? 5. Y equals -2/3 x plus 5. So to recap what we did today, we discovered what slope-intercept form was, right? The m means the slope, the b is the y-intercept. I gave you a visual of what it looks like. Y-intercept is where it crosses the axes, the y-axis. Slope is rise over run. Then from there, given an equation in slope-intercept form, we were able to identify the slope and the y-intercept. So y equals 3x plus 2. The slope was this 3, the y-intercept 2. And we went down that route. Last learning target, we created an equation given our slope and our y-intercept, always using slope-intercept form.